It's 2025, 4 years since I bought the very first Framework 13 laptop, and today I'm installing my fourth upgraded mainboard. I kicked things off with the Intel i7-1165G7 in 2021, upgraded to the i7-1260P in 2022. I skipped over the 13th gen and Core Ultra 100 series, then jumped to the Ryzen 7 7840U in 2024, and now I'm refreshing my Framework 13 once again, this time with the brand new Ryzen AI 7 350 mainboard. So was this a smart upgrade, or should I have waited for a potential Intel Core Ultra 200 series board? Let's find out. It's the money. Hey guys, CJ here with Elevated Systems, and if you're watching this, chances are you're already familiar with Framework and their philosophy of designing modular, user-serviceable, highly repairable, and upgradable tech. This is the Framework 13, the ultra-portable thin and light laptop that kicked everything off back in 2021. Now, I'd love to say this is an original Batch 1 Framework 13, but let's be real, while it started that way, so many of its components have been swapped out or upgraded that it's basically a whole different machine. And today, it's getting its fourth upgrade and sixth mainboard overall. In this video, I'll give you a quick demo of the mainboard installation process while highlighting the other upgrades my Framework 13 has picked up along the way. Then we'll dive into the specs of the new Ryzen AI board before jumping straight into performance comparisons across all four of the main boards that I've used. Installing the main board is pretty straightforward and can be done entirely with the screwdriver that comes with the laptop. Loosen the caps of screws on the bottom panel, open up the laptop, lift the input deck, disconnect the ribbon cable, and now we have access to the internals. There are 6 connections to the main board. Starting at the top right, there's the webcam module connection. Moving counterclockwise, we have the display connection, the audio module ribbon cable, just pop open the clasp, the speakers, the battery, and finally, the Wi-Fi card. Once everything's disconnected, remove the 5 motherboard screws and lift out the old main board. Drop in the new one, and then just reverse the process to reassemble. While I work on that, let's talk about the other upgrades my Framework 13 has picked up since 2021. Pretty soon after it arrived, I started having issues with the trackpad. Framework replaced both the trackpad and the trackpad ribbon cable under warranty. After that, when I upgraded to the 12th gen Intel mainboard, I also picked up the CNC top cover panel and upgraded hinges, which helped cut down the screen flex and wiggle I pointed out in my original review. When I installed the Ryzen mainboard, I upgraded from the 55 watt hour to the 61 watt hour battery. Somewhere along the way, I also upgraded to the new 80 decibel speakers, and I replaced the bottom chassis assembly after losing 2 of the mainboard screw inserts. Not a problem most users will run into, but I tend to disassemble this laptop more often than most people. Most recently, I swapped in the new 2.8K variable refresh rate matte display. At this point, the only original parts left in this laptop are the keyboard, input cover, and webcam module. With this mainboard upgrade, I'm also stepping up from 32 to 64 gigabytes of DDR5 5600 RAM. I'm keeping the RZ616 Wi-Fi 6E card for now since the new Wi-Fi 7 RZ717 card isn't available yet, and I'm still on Wi-Fi 6E at home anyway. I'm also holding on to my 1 terabyte Gen 4 M.2 drive. With the laptop reassembled, I first booted into the already installed Windows 11. Aside from the fingerprint reader not working initially and needing to reset my PIN, which is totally normal after a hardware swap, everything went smoothly. I connected to Wi-Fi, completed the PIN reset, and once inside Windows, I installed the new Ryzen AI driver pack. Everything functioned perfectly after that. I ran a couple of quick tests right away, and while I did later reinstall a fresh copy of Windows 11 24H2 for the official testing, performance remained consistent. So if you are upgrading, while a clean install is recommended, it's not necessary. If you're going from Intel to AMD, I just recommend uninstalling Intel specific Wi-Fi, Bluetooth, and graphics hardware drivers first. So let's break down the specs of the 4 main boards I've tested in this Framework 13, starting with the Ryzen AI 7 350. This chip has the same 16 thread count as last year's Ryzen 7 7840U, but the architecture is completely different. Instead of the previous generation's 8 full power Zen 4 cores, the AI 7 350 employs a hybrid architecture comprising 4 high performance Zen 5 cores and 4 efficiency focused Zen 5C cores. The Zen 5C cores are clocked at 2 GHz base and boost up to 5 GHz. The integrated GPU transitions from the 12-core RDNA 3-based Radeon 780M in the 7840U to the 8-core RDNA 3.5-based Radeon 860M in the AI 7 350. But there's a clock speed bump from 27 MHz to 3000 MHz. That cut in GPU cores likely reflects a shift in design focus. The AI 7 350's NPU now helps deliver a total of 66 TOPS of AI performance, double the 32 TOPS of its predecessor. Both Ryzen boards were tested with the same 64 GB of DDR5600 memory, and with the AI 7 350, I was able to designate up to half of that, 32 GB, for VRAM. I chose to allocate 16 GB, which was more than enough for testing. The 7840U, on the other hand, was limited to just 2 GB of VRAM allocation due to UEFI restrictions. Okay, time to jump into the testing results. There's a lot to cover, so feel free to pause as needed. I ran every test using the best performance, the red lines, and best power efficiency, the orange lines, power profiles across all main boards, except for the 11th gen Intel board. Unfortunately, I damaged the webcam connector during reinstallation, and while probably not critical, I don't want to risk a ground short, so I cut testing short on that board. I also plan to include battery-only tests using performance mode, the green lines, for all the boards, but I didn't start doing that consistently until I got to the Ryzen systems, so you'll see a few missing data points for the 12th gen Intel. Starting with raw CPU performance in Cinebench 2024, the Ryzen AI shows an 11.8% single core uplift over the 7840U and comes in 20 and 42% faster than the 12th and 11th gen Intel boards respectively. However, it also sees the steepest performance drop when switching to power efficiency mode or battery operation. That said, thanks to its significantly higher CPU power draw, up to 54 watts compared to about 28 to 30 on the 7840U, the AI 350 manages to land just 4% behind the previous gen Ryzen in multi-core performance, despite having 4 fewer full power cores. Neither Intel CPU came close to matching Ryzen's multi-core numbers. Interestingly, all CPUs showed a slight multi-core performance bump on battery, suggesting, like with desktops, a mild undervolt can actually help mobile CPUs under certain workflows. Moving to Geekbench 6, we see a 10.6% single core improvement for the AI 350 over the 7840U and a massive 23 and 91% lead over the 12th and 11th gen Intel chips, with behavior remaining consistent across power profiles. In multi-core performance, the AI 350 leads the 7840U by nearly 10%, though again, battery and efficiency modes take a toll across all the boards. The cutback to 8 GPU cores does hurt the AI 350 in compute-heavy workloads. The Geekbench 6 OpenCL test shows it trailing the 7840U by about 19%, although both still outpace Intel chips. In Blender, using the CPU as the render device, the two Ryzen boards are neck and neck, each more than doubling the performance of the Intel CPUs. Switching to iGPU rendering, the 780M pulls ahead by about 19% thanks to its extra cores. The Intel iGPUs in this case don't qualify as usable render devices. In more everyday creative workflows, the AI 350's faster single core bursts give it a 14% edge in Photoshop over the 7840U and an 84% jump compared to my original 11th gen configuration. It also delivers better scaling in lower power modes than the 7840U. That said, in Premiere Pro, which relies heavily on GPU and higher sustained CPU performance, the AI 350 falls behind the 7840U by 13%, though it claws back some ground when running on battery or in efficiency mode. In Underwriter Laboratories ProCyan Office Productivity Benchmark, which tests moderately multitasked Microsoft Office workloads, the AI 350 leads by 6% over the 7840U and shows a solid 26 and 42% gains over the 12th and 11th gen Intel boards. If your work is browser-based or web app heavy, you'll also see uplift here. Now, as I say every time I upgrade this machine, the Framework 13 isn't built to be a gaming laptop, but any laptop can be a gaming machine if you choose the right games and settings. Unfortunately, we're starting on the back foot with the reduced iGPU, and in the 3D Mark Night Raid test, the AI 350 falls 6% behind the 7840U. In Shadow of the Tomb Raider, at native resolution and low graphics setting, average FPS goes from a completely unplayable 16 on the 7840U to a slightly better but still unplayable 19 FPS on the AI 350. Now, if you guys want a proper realistic gaming deep dive on this platform, like I did for the 7840U last year, let me know in the comments. What I will be doing is a Linux-focused deep dive on the Ryzen AI 7 350 over on my Lifting Linux channel, including more developer-leaning benchmarks. So make sure you're subscribed there if that's your thing. But let's wrap up the performance section by seeing if the Ryzen AI chip lives up to its name with some actual AI workloads. For this, I used the UL ProCyan AI text generation benchmark, which measures how quickly a system can run popular language models locally without relying on the cloud. It simulates real-world use cases like answering questions or generating summaries using a mix of well-known models, including Phi 3.5 Mini, Mistral 7B, Llama 3 8B, and Llama 2 13B chat. These models are optimized to run more efficiently on local hardware using int4 quantization techniques that reduce memory load without sacrificing much accuracy. Unfortunately, like most AI workloads right now, none of these models are lightweight enough to leverage the NPU directly, so they fall back almost entirely on the integrated GPU. That means the Ryzen 7 7840U with its larger 12-core Radeon 780M actually outperforms the AI 7350 in this test. So while the new chip is a big jump in AI inference potential on paper, there's still work to be done before that neural processing unit becomes a meaningful feature in real-world AI workloads. Overall, the Ryzen AI 7350 delivers about a 7 to 10% uplift in general performance over the 7840U, especially in CPU and productivity tasks, though it still lags behind in GPU-heavy workloads due to the trimmed-down iGPU. But what does that mean for power efficiency? As usual, I boil it down to the most important factors. First, in terms of battery life, the new Ryzen AI 7 350 equipped Framework 13 clocked in nearly half an hour less runtime than the 7840U in the UL ProCyan Office Productivity Battery Life test. While some laptops equipped with the AI 7 350 have been lauded for impressive battery life, in the Framework 13, the results were less stellar. So despite using an industry standard battery life benchmark, I was skeptical of my results. I make it a habit not to read or watch reviews on products I'm actively testing, but for a sanity check, I asked ChatGPT to summarize what reviewers were saying about battery life, and apparently most reviewers are reporting similar results. Honestly, 4 years ago, hitting a full 8-hour workday on battery was the goal, but now with Apple's M series chips and Intel's Lunar Lake platform pushing past 2 full workdays of real-world battery life, this feels like a step backwards, especially when it can't even match the previous generation's efficiency. I also noticed that in performance mode, the fan ramped up more frequently and noticeably louder than it did with the 7840U during moderate multitasking, and the input deck or keyboard got a few degrees warmer under load. That said, it's still miles ahead of the jet engine levels I experienced with the Intel boards, and the fan remains dead silent at idle or in efficiency mode. So now we've reached the point where I typically assess all the data, consider the $700 price tag of this new mainboard, and tell you whether or not I think you should upgrade your Framework 13. But the truth is, you guys, my audience, are smarter than most, and if I've done my job presenting the facts clearly, then you already have everything you need to make that decision for yourself. That said, I'll go ahead and complicate things a bit for some of you. Understanding Framework's philosophy, I initially assumed they'd skip supporting Intel's Lunar Lake CPUs due to their use of on-package memory, but then I pre-ordered the new Framework desktop a couple of months ago, which uses soldered RAM. So now I'm not so sure. One of the downsides of Framework being a private company is that they don't have any real motivation to publish a product roadmap. That means they could announce Lunar Lake mainboards tomorrow, potentially leaving those who just bought the Ryzen AI board with a case of FOMO. And if that happens, if Lunar Lake really does deliver 16 hours of battery life and significantly better integrated graphics performance than Ryzen, is it worth rethinking whether socketed memory may be worth giving up to enable those improvements that soldered RAM can deliver? Now, I'm not taking sides in this debate. I personally don't think we'll see a new Intel board until Arrow Lake Mobile hits the market, but I'd love to hear what you guys think in the comments. Then there's also the fact that for the first time, Framework is offering a Ryzen AI 9 HX370 as the higher end mainboard option. And that's not just a clock bump mainboard like the previous generations. It's 4 additional C cores and a full 16 core iGPU. Of course, that power likely comes with reduced battery life, and at $1,000, it's far from a casual upgrade. All right, guys, that's it. If you found this video helpful, please give it a like. For more in-depth testing, including Linux-focused content, subscribe here and check out my Lifting Linux channel. And remember, I also want to hear from you about a gaming-focused overview. Thanks for watching, and I'll see you in the next one.